Okay, we're year 10, unit 1. This is a wee bit then on bounds. So the upper bound is the biggest possible value that will round to give the measurement. The lower bound is the smallest possible value that round to give the measurement. Look at the degree of accuracy to determine what bounds you're looking. So illustrating in a number line the range in which the following numbers lie. So 1.7 has been given to 1 decimal place. So what's the biggest number it could have been, and what's the smallest number it could have been? Let's actually do it. We'll kind of go backwards maybe from the number line and see what we end up with. But our number line is going to be our answer. So we'll stick 1.7 here. If it's bigger than that, it's going to be 1.8. It's bigger than that again, it's going to be 1.9. If it's smaller, it's going to be 1.6. If it's smaller again, it's going to be 1.5. So it's been rounded to 1.7. It must be kind of closest to 1.7. So the cutoff is going to be round about here, and the cutoff is going to be round about here. What's the cutoff at this end? Halfway between here and here is 1.65. Halfway between here and here is 1.75. Now we still need to have a wee think about these. Okay, I'm going to call it X, and then here. If I asked you to round 1.65 to 1 decimal place, you will get 1.7. So we're good. It can be 1.65. So we can go then from there. If I ask you to round 1.75 to 1 decimal place, it's going to go to 1.8. So it can't be, the number we're dealing with, it can't be 1.75. So we then kind of do our less than here. So the values that it can take are in between 1.65 and 1.75. That's what this wee thing means, that the number X is in between those two values. The equal sign here means it can be 1.65, but it can't be 1.75. On the number line, we draw two circles at each of these values. We get a ruler and we join them up. And if it can be that particular number, we colour in our circle. And we end up then with our number there. So that's it illustrated in the number line. Let's take a look at part B. 3.73 corrected 2 decimal places. So again, let's do something similar. 3.73 we'll have bang in the middle. 3.73. If it's too big, it'll be 3.74. If it's bigger than that again, it'll be 3.75. If it's smaller, it'll be 3.72. And smaller again, 3.71. So if a number has been rounded to 3.73, where must it be? It must be closest to 3.73. It's going to be in between here and here. What's this number here? That has to be 3.725. I haven't left myself very much space here. That's okay, life will be going on. What's this number here? It's going to be 3.735. What can X be? I'll maybe do my wee line down below. Should have made a bit more space. As with here, 3.725, I asked you to round this to 2 decimal places. You'll of course get 3.73, which is good. So it can be that number here, and then it can't be this number here. So my circle here is going to be coloured in. My circle here is not going to be coloured in. And look down close. Alright, example 2 is a little bit different because it's discrete, as in it have to be whole numbers. The number of pupils that attend the school is given us 1200 to the nearest 100. What is the range in which X, the number of pupils that actually attend the school, lie? So X has to be, let me see, if it's 1200 to the nearest 100, you can go 1250, but 1250 is going to give you 1300, so you've got to go one fewer than that. So 1249, and then 1150 here. If I go to 1149 and round that to the nearest 100, I get 1100, so that's no good. So 1150 is my cutoff there, and it can be that number. And then 1249. Notice now it's different. Both of these have wee equal signs here. It's because it has to be whole numbers. It has to be discrete, as opposed to these wee ones up here. And notice the difference in those. I hope that makes sense.